Thank you, Mohammed. Good morning, Salaam alaikum. Uh, for thousands of years, our ancestors looked up in the sky and wondered about all those stars in the sky. And particularly, they noticed that there are some of the stars which actually move from one season to the next. And these were the planets. And just imagine in our generation, we actually visited each and every one of those planets. For in our generation, we put our footprints on the moon. We put rovers on Mars. So when you think about it, that after those thousands and thousands of years, the boldness of our generation has enabled us to explore the universe around us. So what I'm going to tell you today a little bit is about what we have learned, why do we explore, and what kind of people actually made that actually happen. So if you look at the picture which is displayed now, this is a part of the sky where if you take a dime and put it at the end of your hand, that's about the area that's covered by that picture. And you see there are hundreds and hundreds of galaxies, and each one of these galaxies literally has millions and billions of stars in it. So when you think about it, it's an amazing world that we live in. So let me tell you a little bit more about this. Now, if you zoom in, these are examples of a couple of galaxies. And as I mentioned, each and every one of them actually forms billions of stars which are there. And somehow around one of those stars, there were planets which formed. And we were fortunate that on one of those planets, it had the right environment, the right temperature, the right chemistry, that led to actually cells, and these cells actually led to life that we see it around us. So sometimes you wonder, how did that happen? How did we start from those galaxies and stars, and how did it lead to life today? And particularly after 3.8 billion years of evolution, we ended having the step conference. So people don't realize that it took 3 billion years for you and I to be sitting in this room here. So the question is, how did that happen? We started from the Big Bang, where it was a lot of particles which were formed. And here we have life, intelligent life that we are talking here. So what we try to do in our exploration is to write what I call the book about how did we start, how did the planets form, how did the galaxies form, how did life evolve, and is life common in the universe, or is it only unique, to this planet here? So the area which we tend to focus on is the planet Mars. And that's because Mars is fairly close to us. It takes only 9 months, to travel to Mars. And Mars has a fair amount of similarity with our own planet. Even that at first look, it looks a little bit different. Mars is about 1/4 the size of Earth. It has polar caps. You look at the picture at the bottom, these are the polar caps on Mars. And they expand and shrink depending on the season, like the polar caps on Earth. And they are made of water, H2O, like what you drink in the bottle, plus a little bit of additional material in it. And if you zoom on Mars, you see a lot of similarity. The picture on your right, that's a Grand Canyon on Mars. The picture on the left, that's a Grand Canyon, on Earth. There are volcanoes on Earth, there are volcanoes on Mars. The one on the left is a volcano in California. The one on the right is Mount Olympus, which is the largest volcano in the solar system. It's on Mars. It's about twice the height of Mount Everest. So it's a huge volcano. Now it's extinct, but clearly when it formed, actually there was a lot of activity, geologic activity happening on Mars. I give this as a test to my student. Guess which one is a picture on the surface of Mars, taken from the rover, and which one is a picture on Earth? And even sometimes I forget, which one is which, because they are so similar. The picture on the right is in Death Valley in California. The picture on the left is on Mars. So when the first astronaut lands on Mars, she thinks she will be in the desert on Earth here. So the point of all these pictures is to show you that there are a lot of similarity between Mars and Earth. The geologic activity is the same. What we found with our rover, that the composition is the same. We believe in the past there was water on Mars. Now it's frozen and below the surface. There was volcanic activity, that it means there was heat. So the key question, if we had the same ingredient and the same phenomena, could have life started on Mars? And if it did, where is it? How far did it evolve? Did it evolve to the level of cells, or did it evolve to the level more advanced? So that's what we are trying to do with our mission that I'm going to describe to you in a minute. So as we speak today, we have 2 rovers which are roving around Mars. Just think about it. One of them for 13 years has been roving on another planet. So when you think about it, even me being a technical person and I was responsible for these missions, I find it amazing that we have rovers driving on another planet and actually every day doing experiment, making measurement and sending us the information. The one on the left is Opportunity, which has been there for 14 years. And the one on the right is Curiosity, which we landed about 4 years ago. When you look at Mars, if you are a geologist, this will look to you like a dry lake bed. This will look like there was actually a lake, and as the water evaporated, the salts were left on the surface, and you see this layering, which is very common in dry lake here on Earth. This is a picture taken about a month ago on it, and it looks like any of the sand dunes in the desert here. You can go outside of Dubai, and it might look like you are on Mars, or vice versa. So let me tell you a little bit about the challenge of getting to Mars, the engineering challenge, because kind of reflect a little bit of what's happening here in the conference, that you have people with imagination and daring who can do great things, you know, if they put their mind to it. So when we sent Curiosity to Mars after 225 million kilometers, we have to land within a 2-kilometer circle. Otherwise, the lander would have burnt. Now, let me give you an idea what that means. That means, like, if I go outside my office in Los Angeles and hit a golf ball toward Dubai, the golf ball has to go straight in the cup. That's how accurate we have to navigate those spacecraft to do what I just mentioned. And to make it a little bit more challenging, if you are really a good golfer, the cup is moving, because Mars is not fixed, Mars is moving. So even with that, we had to land it that accurate. So we had to develop a lot of technology to make sure we navigate it so accurately. Let me give you another illustration of an example. At the speed we were arriving, the energy in the capsule, which was entering the atmosphere, was the equivalent of 18,000 race cars going at full speed. And we had 7 minutes to stop and land very softly on the surface. Otherwise, we would have crashed. So as you will see in the video I will show in a minute, we use heat shield first to slow us down, like when you put your hand outside your car, that kind of slow you down. And that heat shield will heat up to be hotter than the surface of the sun, but it has to survive. Then after that, we open a parachute at supersonic speed. They are the largest and fastest parachute ever built. Then even after that, we're still coming too fast. We use retro rocket to slow us down, and then we hover and sky crane the rover. All of that to be done in 7 minutes. And everything has to work perfectly. So what I'm going to do now is I'm going to transpose you to the mission operation room at JPL, the day we landed, and show you what was going on in that room, and notice, you know, the age and the mix of the people who are actually running that mission. Yeah, can we move the sound up a little bit?
Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do. We are standing by for guided start of guided entry. We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. It is starting its first bank reversal. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. The parachute decelerating. Heat chill has separated where we found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending. Standing by for backshell separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane has started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
Got thumbnails.
Today, right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars. This is an amazing achievement.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity marks what is really an unprecedented technological tour de force. It will stand as an American point of pride far into the future.
Well, tonight was a great drama that was played. I could only think of the words of Teddy Roosevelt as I was sitting there. It is far better to dare mighty things even though we might fail, than to stay in a twilight that knows neither victory nor defeat. Needless to say, this was a very exciting and very tense evening. And the reason I show this kind of video for this kind of audience is after 8 years of work, thousands of engineers working on it, failure could have happened. I mean, there was no guarantee of success. I mean, people did their best, they worked hard, we did all the testing. But as you can see us when the landing was happening, everybody was very, very nervous. And as you heard at the end, I use a quote from President Teddy Roosevelt, that it is far better to dare mighty things, even that you might fail, than just sit in the twilight and not do anything. So that's a message to all the young people. Dare mighty things. Even that you might fail, that's okay, you learn from it, from a failure. But if you don't try to push the limit, you will never advance. And it's great to see young people here, you know, hoping to be entrepreneurs or whatever, trying to push the limit in advancing our knowledge and our capability in our economy. Now, let me take a couple of slides and tell you a little bit what we are planning to do next. See if I get... So the next mission we are planning to do, we are going to put a rover on Mars, which we are building as we speak, very similar to the rover you saw. But the purpose of this one is to drive around, look at interesting rocks, take samples of them, put all the sample in one location, so later we can go land on Mars, collect those samples, put them in a little rocket, launch it in orbit, put the samples in orbit, have a spacecraft rendezvous with them, and bring them back to Earth. Piece of cake. Just a little bit of an engineering challenge, you know, for the young people to do that. And that way, by bringing the samples, we can analyze them here on Earth to see what they are made of. And we're going to add a little twist to it. We're going to put a little helicopter, like what you are seeing here, where the helicopter will fly in front of the rover and actually survey the area so it helps the rover drive to the local area. Because one thing I forgot to mention, it takes 7 to 14 minutes for the signal to get to Mars and 14 minutes to get back. So you cannot joystick the rover. The rover has to be smart enough that we tell it, okay, for today, we want you to do A, B, C, D. And then the rover by itself will drive, avoid hazards. If it's too steep, it can backtrack, look at a different route, go to the rock, drill in it, take samples, measure them, all autonomously to do that. So having a helicopter which will tell them ahead of time what's in front of it and what are the interesting area will be of great help. Now, many of you will say, well, big deal, we build drones here in Dubai and everywhere. Well, the challenge here is Mars pressure is 1% of Earth's pressure. So this is like flying a helicopter at 30,000 feet, which has never been done. And on top of that, all the electronics, all the cameras, all the guidance has to be within 1 kilogram, because that's all what there is allocation for it. So it turned out to be a little bit more challenging than it seems. The other thing we're going to include in this one is to really bring virtual reality to the public. You know, today there are literally hundreds of scientists involved in it, so they sit down on their computer and communicate back and forth. On this mission, we'll be able people to put, you know, glasses on, and anywhere you are around the world, that will transpose you as if you are on Mars. So you'll be walking next to the rover as the rover is driving, and you are looking what the rover is seeing. And you can debate and discuss and say, okay, this looks like an interesting rock. We really want to have a sample from it. And the command will go up to the rover, and the rover will sample that thing. And you can even bring some to STEP conference here, and you put them on, and you are part of the mission to do that. So basically, that will bring the public to be part of the whole exploration that we're doing. And not to go too far, the United Arab Emirates, it's great to see that the United Arab Emirates is planning to send an orbiter to Mars in 2020 or 2021. And here you see the team that is doing that. They look to me like they are all high school kids, but in reality, they're a little bit older. I have met with them, and we have had a number of discussions. So it's great to see that even the Arab Emirate is bringing this exciting endeavor and bringing back the Arab world to be one of the leading organizations or leading countries to actually do space exploration. And I want to end by, people always ask me, how did you get there? You know, how did I become the director of JPL, and you know, we have 6,000 explorers doing that? Well, I was like you. I was a young person who grew up in Lebanon. After high school in Lebanon, went to France, did my college. I was very excited about science, and I believed that anything, you know, is possible, and that's what led to a lot of things. I did a lot of geologic work in the Middle East, using satellite data to map the geology on Earth as an example of how to map the geology on Mars and the different planets. You see me here on the left, I'm in Egypt when I was younger with a lot more hair, and on the right, I was in Oman, you know, next to the empty quarter. And the fun thing about doing this, there is the science part, but the other fun is actually meet, you know, a lot of explorers. So on the left is Cousteau, that many of you know about it. On the right, the people who saw the Martian movie. How many of you have seen the Martian movie? That was the captain. That's Jessica Chastain. She came and spent a couple of days at JPL watching us of how do we actually operate the rovers, you know, so to help her with the Mars activity. So that kind of give you a little bit kind of snapshot about, you know, what I call the golden age of exploration. And that's only talking about Mars. If I had 5 hours, I would have told you about every planet we have visited. Thank you very much.
Thank you so much, Dr. Ashi. It's always fascinating to hear what you've been doing throughout the years. And since we are here in Dubai, I wanted to start with talking about the Arabs and their field and their contribution in astronomy. Now, as we all know, the Arabs were pioneers when it came to the night sky. And in fact, many of the stars are named after Arabic names. Now, besides the plan for the UAE to actually send a mission to Mars, why do you think Arabs in general, they lack the knowledge as well as the investment in the field of astronomy or space exploration? What happened?
Yeah, I mean, we have to remember that the Arab world was a leading part of the world, you know, in exploration, in astronomy in the 7th, 8th, 9th, 10th century. So the Arab world has the same, as smart as anywhere around the world to be able to do this exploration. Unfortunately, it was a dark age for a couple of centuries. And I think the issue now is to invest into the young people, to educate them and really get them excited about exploration again. And I'm glad to see that I'm involved in a number of organizations here. I'm glad to see particularly in the Gulf countries, in Saudi Arabia, Lebanon, there is a lot of investment on education. And you need educated population to do that. It's not a question of money. I mean, the money clearly is a factor, but you need an educated population and opportunities for young people to work, you know, in this area. Unfortunately, there is a fair amount of instability in the Middle East, so that could be a factor. But I'm very hopeful. I mean, looking at what the Arab Emirate is doing related to Mars, when I asked the head of the space agency in the UAE, why are you doing, you know, this mission? He said, well, we just want to inspire the young people. That every dollar we are spending, if it inspires the young people, then you have people who not necessarily become astronomer or space, but they could become entrepreneurs, but they are inspired in doing great things, you know, to go beyond the limits. So I think every dollar spent will inspire the young people, and I hope 10 years from now, 20 years from now, the Arab world will be as leading as the United States or Western Europe.
Yeah, thank you. And let's talk about extraterrestrial life. Since we have a very short time, we have to move from a topic to another. Now, we know that we live on one planet around one star in one galaxy. But inside this galaxy, the Milky Way, we have hundreds and billions of stars. And if you zoom out a bit more, there are billions of galaxies in the universe. Now, was it, knowing that fact that there are this number of stars and planets around these stars, was it really a surprise that recently we discovered TRAPPIST-1?
Yeah, as Mohammed said, and I showed you the picture, there are literally billions and billions of stars in this universe. And what we're finding recently with a mission called Kepler, as well as from ground observation, that almost every star has planets around it. And there are big planets, small planets, there are planets which are very cold, planets which are very hot, but also there are a number of planets which are in the right location relative to the star. They are not too close, they are not too far, that the water is liquid. And water is very critical ingredient, you know, for life. So the likelihood of having life in the universe is very high. We don't have a proof for it, but I think the likelihood, because the chemistry is the same, the composition is the same, the laws of physics and law of biology and chemistry are all the same. So I think the things that life only occurred here would be really arrogant from us. I mean, we are a bunch of arrogant people. You know, we think we are the best, we are the only, but in reality, life probably exists everywhere. Now, in the near term meaning the next couple of decades, we're focusing on the planets in our solar system. So an exciting mission that I have not mentioned here is a mission to Europa, which is a satellite of Jupiter, which believe have an ocean just below the surface, and what means that could be life today, you know, in that area. So we're planning a mission to go and orbit and land on that satellite, drill our way through the ice, and have a submarine which go in that ocean and analyze what is it made of and could there be life in it. So I personally believe that it's very likely that there is life to some level in our solar system, and no question there is life in the universe. But as a scientist, until we prove it, I cannot say yes, absolutely true.
But statistically, this is what you were talking about.
No, and that's the purpose of exploration.
Then what is keeping us from actually seeing this type of light? Is it funding, we're not having enough funding, or is it the technology, not possessing the technology needed?
No, I would say in general it's funding, how much resource and how much will the nations are willing to do, because technology, we can invent it.
Yeah.
I mean, I remember, you know, when I was a young kid, flying on an airplane was something amazing.
Yeah.
I mean, now I don't think twice about it. I just drive to the airport, get on an airplane, and fly to Dubai. That's all in a lifetime. So I think the technology, even that there is need of technology, I think we are smart enough collectively, we can develop that technology. It's a question of the commitment and the will and the investment that is required to be done by governments to be able to advance the kind of technology.
I want to end with this last question, and this will take us back to the Big Bang, where everything started. Now, we know what's the Big Bang, kind of, but we don't know what was before the Big Bang. Do you think this fact that we have no idea what was before the Big Bang, will we be always limited about this knowledge, or do you think at some point of our lives we might know what was before this Big Bang?
Yeah, I mean, nobody knows because invention can come at any time. Breakthrough can happen at any time. Even the Big Bang, we didn't know about it until few tens of years ago. And it's interesting. Your question is very interesting. I love taking young kids to tour around JPL, and always the young kids tell, okay, there is a Big Bang. What was before the Big Bang? It's always the young people who ask those questions because they are curious. They are not limited like us, with practicality. And so I wouldn't be surprised that sometime in the next few decades, somebody will come with a measurement or a theory or a discovery, which will give us an insight of actually what are before the Big Bang. So stay tuned.
Okay, thank you, Dr. ElAchi. It's always a pleasure to have you. Thank you.